Here is me trying to do spatial data science suitability modeling with ArcGIS Pro from the course and the MOOC Spatial Data Science, the new frontier. So let's dive in. I'm not showing you how to get into this MOOC or how to use ArcGIS Pro like from scratch. I'm just walking through my suitability analysis modeling. Also, it's from a course given by S3, Spatial Data Science, the New Frontier. So, yeah, there we go. So you can see, I am like basically following the instructions. So, key things to note about suitability analysis is you need to go through several steps before you do suitability analysis, and this is you need to define the problem, right? Basically, what are you trying to measure? What are you trying to do? Identify the criteria. So, like, what do you want to use to do that analysis? Then number three is drive the criteria. If you do not have like the data, like given here in the example, slope is a derived criteria, and this is derived from elevation data. Then you need to transform the criteria because, as you can see, elevation is meters above sea level. Then you see something like slope is like past a degree. Then you have something else like distance from the road. So you probably do Euclidean distances so that you can get a raster where you can now reclassify that. So that's what you mean by you need to transform the values, then you weight and combine, and so all those things that you want to use in the analysis, you combine them and then you give them a weight, and then you locate the site, like whatever it is you wanted to do, and then you analyze the results, and then you rinse and repeat. So yeah, basically that's how you go about it. So in this scenario, it's again given by Esri. It's a global company that wants to identify the best location for its carbon neutral headquarters. So they want it to be located in the state of Vermont, and then so that's what we're gonna do. So basically, that you have to identify the criteria. This is the criteria that have been identified for us by S3, and this is like based on the suitability. And again, this you have to go do research, and you also have to have domain knowledge when you're creating this criterion. And so, like in this case, the wet flats and high density areas are less preferred, and the steep slopes are less preferred. You need to be closer to major road, but you don't want to be visible from the roads themselves. So in others, you can see like the derived criteria. You can see here is you use radius clear to get the radius, you get elevation to get the slope. You use the distance from the road to get the distance from the road. You use viewshed analysis to get the viewshed layer, and then you get the views so that you can create basically use that in your evaluation. Then again, this needs to be green energy dependent, so they need to be a place where there is high solar radiation, which is preferred. So you find the solar layer. You need to be closer to electric lines, so that you can if you have in more energy you can distribute it into the utility grid. Then you need, in this case, in the state of Vermont, you need to be in the south facing angles, so you need the aspect. Again, aspect is a derived thing from basically from again elevation. So again, closer to amenities, it needs to be closer to the city of Barrington, and it needs to be closer to recreational areas and residential areas. But at the same time, it needs to be preferred to be away from the protected areas, from the biological areas, from wetlands, and from streams. So yeah, went ahead, downloaded the files, and then I need to go and open ArcGIS Pro. So in my case, I need to just come in here. I have the data downloaded in the Spatial Data Science, and then where I need to go is come into Suitability and open the headquarters. Okay, Yes, ArcGIS Pro runs. Give it a moment. Here you go. It's loading the data. I saw it's faster than this after it loads. As you can see, this is the area. This is where you're gonna get, basically this is the area of study and this is the, so if you can see, this is the study mask, this is the hill shade, this will be the elevation model that we're using. You can see the major roads where they are, you can see where the bridge, the ridges, so for visibility. And so it creates that where it tells you these are views. So this is basically again a raster that shows the different views. Then this is the radius. As you can see, we have several radiuses. So as you can see here, I have very many different radiuses. And then there is study mask, then there is those are things like, see, like now we don't have slope, you need to generate it from our elevation. So yes, just do that. So the first is we drive a criterion. So in our so one of the things that we need to do is each criterion is a suitability model begins with a base data set. That's when you use that data set to generate a criterion to use. So the slope prayer is one of the 4 years that are required for building a site. So what we need to do is we need to create elevation to create slope from elevation. So in ArcGIS, it's just simple. You open the geoprocessing and you do basically slope. Yeah, you could use slope or there's surface slope. There's this in this spatial analysis, basic spatial analysis tools. But you can also use according to S3 surface parameters. See again, this is now a combining tool that has all those slopes aspect, like basically all in one tool. And my ArcGIS Pro is slow. What's up? Okay, it opens. So what we need is we need to get this elevation in the input layer, and the output is we're gonna call it slope. And you're gonna want to mask so that it only processes where the just our area of study. So in this case will be the study mask. And so what we want to do is make sure slope is, and then you need to do the local surface type, like it uses by default the quadratics, and you can see there is more like a quadratic surface glitch is this one will be fitted to the neighborhood cells, and then the biquadratic will be fitted to the neighboring cells. I mean, basically, this is just maths. I'm gonna get to that. So let's use the quadratic, and then we need to use like still let's use 30 meters because our elevation is also 30 meters resolution, and then run the tool. So that what we do. Once it runs, it generates for us the slope. Again, there is a slope, and it ranges from, in this case, it ranges from 0 degrees to 58 degrees. So that's good. So then we need to derive the remaining criteria. Remember, we had a list of criteria we need to be identified. Remember, we have, let me show you again. As you can see, we have several criterions that we need to have. So basically, we need all the solar, we need everything, a distance from the airport, from the recreations, from the residentials, from protected areas, from biological areas, from wetlands, from streams, solar, irradiance, and then aspect. So let's drive the others. In this case, after slope, we want to drive, uh, let's see, uh, again, we need to drive the others, which in this case will be the distance from the major roads. Again, now that's again, like I said, this will be a distance accumulation tool. So distance, and then you can look for distance accumulation from the spatial analysis. Again, you click that, and the input features will be the major roads, and then the output we need it to be distance from major roads. Okay, and then we have a barrier feature. Remember, we had a barrier that showed that there's no road that passes there, so we need to put that barrier. And what do we call it? The barrier was green empty bridge. There's a feature here. This, if you can see, green empty, where you green empty. So you can see no major roads pass on top of it. So it's a barrier. There's no way you're gonna get a road. So there's no way of you going past here, wherever, whichever means of transport you're using. So you have to think about going around it. So that's why it's there is a barrier. And so again, let's go to environments. And then we need also again to put it in the mask. Again, let's go into either the last analysis. We need to put it under mask, the mask here. Again, we need to put these things under the study area. So that's why we are going with that. Then we're gonna leave this default and learn it. Okay, as you can see, this has been respected. So you are being told you can go past here. These are the green areas which are closer to the load. So that's good. As you can see, major roads and then visibility zeros. Oof. Okay. So again, now this view zero layer shows the visibility from major roads, and then according to the building site criteria, visibility from the major roads is less preferred. So we are looking for areas that are not visible from major roads. And in this case, in these views, those areas that have that are are not visible from the major roads have a cell value of 0 and are represented using the black. So we want to stay within this black area. So wherever the white areas are not preferred at all because they are visible from the major roads. So so now as the value of the cell increases, it means you're increasing the, the visibility from the road. So yeah. Let's do another one like this. Is now for the values. So you can see So I mean, like for radius, we don't need to. It's a criterion on its own. So we don't need to do anything. We just need to be able to derive to use it in the analysis. Okay. So basically, anyway, I'm following the tutorials as highlighted by Esri. So nothing new. So what we gotta go do is now, as you can see, I'm here on step number 7. You need to create a submodel, and this is how we do it for the submodel. So again, go to analysis, and then suitability model. Okay. We need to disable the auto calculate so that because the model changes as we upright, so we need it so we can recalculate when things are basically we recalculate. So again, as you can see, we need to then we need to come in the analysis workflow from certain okay. Then we need to name. We need to give this a name. Where's the model name? Coordinate HQ building site. And then we need identify restricted locations. This one. So when you are building a code, you can identify the restricted locations within your study area. This will enable you to remove specific locations from consideration altogether. So so you do not need to restrict the location in our settlement now. But so imagine if there was another building somewhere there that you could use, or a military base that you shouldn't even consider. You would basically restrict it from ever being even used in the analysis. So again, so there's that. So that you need to keep that in mind. So again, now let's go to the transformations. That's number 7, 8. Okay. Oof, I'm just talking about numbers. You can see. So you can see, the values of the criteria data sets are relative to the criteria they present. So the radius uses categorical values such as open water, whereas slope uses continuous values like ranging from 0 to 90. So before you weigh them, this two basically all the things needs to be the same comparison landscape. So what we need to do is we need to do the suitability, and then you need to add the rasters. Oof, no, I don't want to open. I want to add. Uh, I don't want to do that anyway. Okay, let's go to a database. This is in the data. There is, here is all our calculated, pre-calculated rasters that we're gonna use. So So we need the radius. Where's the radius? Okay. So this is the criterion, and it has the weight. And then we have a transformation pane. Where is you? So you can see, once you click on it, you get a transformation pane. And then, so what we need to do is we need to basically categorize this. So in this case, uh, so we are trying to get here to this part here. So we want to, this is what we are trying to do. This is visible. So we need to give these things there. So like we need to use field is category, and then we need to give category something like let's do this. Open water is suitability of 1. Developed and open spaces is 5. Low intensity areas are 4. Okay. Medium intensities areas are 3. High intensity areas are 1. So basically, we are just telling the model like this: the open spaces have the some of the one of the highest suitabilities. Like you don't wanna, and like high intensity areas, like that's why you're giving 1 because well, they already have a lot of they have a lot of yeah.
Daddy superhero.
It,
Daddy superhero. Peoples. Peoples. Peoples be under the car. Dada, stand up. Dada.
Gemma, I need to go fast and then I'll finish and come. Please, I need to finish.
Dada.
There, who?
Dada.
What do you mean? Sorry about that. Take care of something. So barren land, an 8. The CDS forest is an 8. The green is a 7. You don't wanna, you remember you are still environmentally conscious. Mixed forest, you don't wanna touch it too much. Shrub, bushes is a 7. And pasture is a 10. And 9. 1 and 5. So you see, so this table will does this preference where what we are trying to do is it defines the preference scale for each category, where 1 is not preferred and 10 is very preferable. So like these ones here, you don't want to touch the wood rods. You are trying very much not to touch high intensity developed areas. You're 50-50 about open space. But again, open water, you can't go into open water. So that's what all this criteria is saying. So let's go and save our map so that we don't lose things. And also, like, it's good, I mean, software always learn to do save as you work. Okay, so that was one. You saw how to transform a categorical layer into the suitability we want. Now, again, now let's go to how to transform continuous criteria for a submodel. So in this step, we transform a criteria with continuous scale, like slope, for building the model. So data with continuous values is what we know is, I mean, like most of geospatial work and analysis, lots of statistics. You're good in statistics, so easy to switch into geospatial work. This type of data, the continuous data is not discrete. Like, I know you get the discrete and continuous data, so I'm not gonna deep dive into that. It's just again me working through the suitability analysis. Okay, the next to input again on the suitability modular. Let's go. We need to add the distance to roads, the slope, and the views. Okay. The criteria table again. Click on it. Click on slope. That's the slope. So this now right now, if you can see now, the slope here is the active in the map. So again, here on the transformation pane is the active one. So again, you see it switches very nicely. It's a continuous function. It's a continuous, yes, it's a continuous data set. So the suitability might will do that. We identify that. So this method applies linear and linear function to transform the values continuously to the suitability skill. So there are some various transformation functions, and each one will vary depending on calculation and application. So in this case, we're gonna try to turn on. If you look at the transform slope, it has been turned into from basically from 1 to 10. So that has been the best way to say it has been calculated to fit into those 10 categories, with the again one being the place where you don't want to be, and greens being the place you prefer to be. So let's try to do calculate. So again, you can see this function being used. We are using MSS small to do the category and give it 10, basically 10 classes. And in this case, the MSS small function is the best function for this transformation because it scales input data based on mean and standard deviation. The smaller values in the input raster have higher preferences. So it's basically true like that. So yeah, you can calculate this. So it does its job and puts the data in there. So again, let's go click on distance roads. Again, the transformations, we don't want to use the MSS small, we want to use small. Again, 1 to 10, does its analysis. You see this is the transformed distance roads. So you can see the greens you want to be in, and then the lead area you never want to be there. So now reach. And then you need to calculate. Okay, let's go to the 0. Again, this is a range of classes. So you need to give them into a specific suitability. So the transform come ahead. So yeah, so you can see it has been already calculated for you. The values, and then so basically you are doing classing binning so that you can say which area like is preferable, like 1 not preferred, or 10 being most preferred. So we have added we have just uses radius, distance, road slopes, and view zeros. So then let's go and do a weighted criteria. Weight the criteria of the submodels. Okay. So there are some certain criteria in the submodel may be more important than the others. Like I would assume in this case, and so you need to put weights on each of these. So to account for these differences, you will weigh each criteria relative to one another before you combine them. So in Pro, we have two different methods that are used to weigh the criteria. That's the multiplier or the percent. When you create the HQ group layer, the multiplier method was automatically selected to weigh the criteria, and then the transformed criteria are multiplied by the value that is specified in the table. So, like, say, a weight of 2 means that the criterion is twice as important as the criterion with a weight of 1, and a weight of 10 means that the criterion is 10 times more important. So, basically, the common weights are between 1 and 2. This is method best you can basically. So, so let's go to the site here. So, view 0 needs to be 1.25. Slope we need at 1.6. Distance to roads at 1.25. And radius is the highest, the slope at 1.26, 1.6. Again, let's do calculate. As you can see, it's auto. At the moment you auto calculate, it shows you what it thinks should be the suitable. The greens are the most suitable, while the other ones are not suitable. You see in the reds here, they are not suitable at all, and the blues here means don't even think about them. Okay, so that's on a calculation level. So can we just then let's just learn this. We just use radius, distance, roads, and slopes and v0. Let's do an initial run. See what we get. So let's save the model. We have run it. So here we go. So this is the suitability analysis. So as you can see, so the next part is let's do a report. Uh, notes. let me first of all rename this so that it doesn't come as Suitability Map 3. I forgot to rename that. And then we can go to Suitability and run it. Okay. Let's go generate report. Alert. As you can see, yeah, once you do that, you set the location for this site and then you kind of just create a report. I'll generate a PDF report with the criteria and how they were used and what was the logic behind them. It's learning. So if I come here and view the report, as you can see, it just popped up on my side here. It's a very nice report. As you can see, gives you the map with a very nice report for you to use. Shows what was happened, the base criterions that were used, how they were transformed, and then how they were combined using the weights, and gives you a lot of information. I am gonna read this, but this is nice if you think from the age of when we used to use ArcGIS. This is the power of ArcGIS Pro. Great. Now all you need is to combine some models. Ooh. So in the control pane, expand the spatial analysis for let's see what this have to say. So you have now this was a submodel. This was a submodel to using those different criteria. Now others have been created. The other three submodels have been created, like HQ access to amenities, HQ like this is what we just did. Then we have HQ energy independence, HQ environmental concerns. So let's go to the So an effective way to work with some models is to create them in the same suitability model container. So you can see the HQ is listed, the one we just did. HQ is listed. So along with the three others. So on the ribbon for suitability model, what we need to do is click new. And then so we need to do the combined model. The combined model. So the input here will not be the criteria, will be some models. And then the yes, let's change these names at least. Hmm. Of so this is suitability is to add the models. So actually let's just go them. Okay, that's one. So we just add created. Then let's add the remaining some models. We need to go into the database that's called suitability some models, and you have three. So click one. You can just click one and then shift, and then it will select all, and then you do okay. And then now we need to go and do the weights. All the submodels are added to this table. The criterion for the input models were already transformed, and the other were people. So what we want to do is each of them has the same level. So let's learn and see the combined one. The reds, you don't want to build there, but you see the greens, that's where you want to build. Now time to go and locate our site. So what we need to do is locate. So okay, this is one of the most important phrases. So this I'm gonna read for it the criterion. Again, remember you need expert domain. So you're an urban planner, you're a manager, you're a store owner. You need to do research to do this. So in the locate step, you need to specify. So you need to specify the total area you need, the number of regions, the characteristics of the desired areas. In this step, so you use the full resolution suitability map to identify the best location for the headquarters using this spatial requirements. So we go to locate. So the corporate shareholders have indicated that they want the educators to be a campus with 5 buildings within walking distance of each other. So after further research and discussion, you use this information to define the following spatial parameters like the site must include 500 hectares of total area. So we're gonna go and do hectares and we need 500. And then the area will be divided into 5 regions. Okay, no two regions can be closer to each other. No two regions can be closer than zero point 0.5 kilometers or further than 2 kilometers away from each other. So these are the parameters we are doing. So let's see. Put the suitability. Uh-huh. Horizon. Total is 5 cares. So circle the fifth trade-off. The valuation method will be this highest average value. Minimum area. No, minimum distance between region is 0.2 kilometers and not more than 2 kilometers. So there's this warning here. This okay. Okay. So let's learn this. So as you can see here, there's also something like regional growth here. It will tell you like how do you think you're gonna expand. Like this one is telling me the number of neighbors using the growth will be okay. Anyway, it's not into that, but anyway. And as you can see, I did not change their name. Let's go change the actual name. And here you guess you can see uh, the areas have been identified that are suitable with all these criteria you have given, and they are here. They are basically here on the green areas that prefer, like we say, these are the most preferable areas. And so these are places where they're not visible from the road too much, but they have a sprawling landscape, 500 hectares that you can use to build your campus. So that's suitability modeling. And you can do more, you can add more to this suitability analysis like population dynamics, government policies, restrictions, air quality. Like it depends on what you're trying to do, what you're trying to create. And so let's summarize the results. This, as you can see, if you turn on the other things here, like radius, for the first C. I don't wanna do the views for now. Okay, so you can see is blue. You see where the suitable areas are saying they're supposed to be the best ones. The first one, which is this, the best, which is here. So you can see it's here. That's the best location to locate this. If I turn that off, you can see it's under this nice hay and pasture. He had given it like a 9 or 10. So yeah, as you can see, we have went from lots of noise to creating a suitability analysis that tells you there's the best city areas to build. And they might be identified, but you do further analysis, you realize why it was not. So yeah, I've come to the end of the tutorial because I don't want to do cost analysis because there's so many things to do. You could do neighborhood connections and much more. Hey, that's it. Bye guys. See you on the next one.